Here's this one.
Yes.
Yeah.
Excited.
So exciting. Well, from here, I'll work my way down. So I'm going to take that, again, I'm going to take that trinomial here. I'm assuming that it will factor. And I think you guys know how this ends because we just saw one similar to it. But I got a leading coefficient that is 1. So I'm expecting x terms in both binomials from this factorization. I just need two factors of 24 that add up to 11. Guess what? It's 3 and 8. Now I'm saying that sarcastically because remember this was x plus 3, x plus 8. We kind of anticipated this would end up being x plus 3 and x plus 8, which it does. Okay. Why did we anticipate that? Because they shouldn't be giving us stuff that's super complicated yet. So we anticipated, hey, they're not going to make us go too far on this. Only on the test, yes, or the written quizzes. So I'm going to drop this and then my denominator, right? I went ahead and factored that out. So let's replace that then with an x plus 3 times an x plus 8. Now, could this numerator be factored? It's kind of like that last problem. I'm not going to factor it yet in case I need to move that stuff over so that I can make this equal to 0. But here I can see that the other two denominators, right? I've got an x plus 3 and an x plus 8. I'm planning to work with these, so I'm putting them in parentheses now so I don't forget about it, okay? Like this denominator right here, x plus 3, it doesn't have the x plus 8 multiplied by it like it does over here. This x plus 8, I'm not worried about that. I'm just worried on this denominator right there. So the x plus 3, I'm going to take it and multiply it by x plus 8. But if I do it to the denominator, I need to do it to the numerator as well. Okay, and if I had more space, I'd write it on this side just so it matches everywhere, but whatever. Okay, now I have that denominator of x plus 8 times x plus 3, same as this one, just in a different order, and that's fine. But now I've got to take this other one. It's x plus 8. I need to multiply it by x plus 3. But if I multiply it in the denominator, I got to multiply it in the numerator as well. And from here, I can see in my numerator, it's going to be x times x. That's an x squared. So I am anticipating a trinomial somewhere in the end here. But since the denominators match, every denominator has an x plus 8 times an x plus 3. Even if the order's changed, I now get to rewrite this without any denominator. So I've got an x plus 8 times 2 plus an x times x plus 3. And this would equal then the negative 4x minus 4. Well, this is nice because we have two distributions on this, right? So we got the 2 times x, which is 2x, and 2 times 8, which is positive 16. Also, we can distribute this positive x. Positive x times x is positive x squared. And x times 3 would be positive 3x's. And this still equals negative 4x minus 4. Okay, that's nice. Let's go ahead and start combining some like terms. I may even move some stuff around, okay? So I'm looking at the 2x's and the 3x's right there. That would combine into 5x's. Now again, I'm going to shift the order so it looks like a regular trinomial for us. That's a positive 5x, by the way, but I'm going to put the x squared as the first term and then the positive 16 constant as the last term in that trinomial. Of course, this still equals negative 4x minus 4. All right, from here, let's go ahead and use some principles of equality to solve. So the negative 4x on the right, I want this to equal 0 in the end. I'd like this just to equal 0. So the negative 4x, I'm going to add 4x's to both sides. Again, make sure you're combining these with like terms. So don't take the 4x and add it to the x squareds right there. So 5x's plus 4x's would be positive 9x's. And then also the 4, right? I can take that and add 4 to both sides. Right, that zeroes these out as planned, and then 16 plus 4 would be positive 20. So I now have x squared plus 9x plus 20. This one, well, it doesn't quite match the original trinomial like the last problem did, but that's okay. So I'm going to take that trinomial, x squared plus 9x plus 20. I'm going to look to factor it, but since that leading coefficient is already a phantom 1, I know it's going to be x and x in the binomials, okay? So what two factors of 20 add up to 9? 5 and 4. 5 times 4 is 20, but 5 plus 4 is 9. So I got a positive 5 and a positive 4. Okay, so my trinomial now factors out into x plus 5 times x plus 4. And again, the order doesn't matter. If you did x plus 4 times x plus 5, you're going to get the same exact answer. A little bit more space here just to end this. So if I could get that x plus 5 in that parentheses to equal 0, then the equation would be true. So solving this by subtracting 5 from both sides, x equals -5. But also the x plus 4, if I could get that to equal 0, then I'd get a true statement, so subtract 4 from both sides, and then x equals -4, okay? Well, we got two answers. I don't see any problems with the denominators, right? Like, if you replace x's with -5, that's okay. We won't get any zeros. If you replace x with -4, again, no zeros. So we do need to check these in the original equation. All right, so I'm going to do this. I'm going to move it over here, though, so I can actually do some work. But I'm going to start with x is -5. Okay, so there's a lot of x's, no problem, because the calculator is going to do all this work for me. I'm going to write it in just so I don't miss anything either. A lot of -5 and a -5 and then a -5. Now, in typing this into the calculator, see this x squared? I got this -5 in parentheses. The other ones don't really matter so much, but this one does. If you don't put this -5 in parentheses, the calculator is it's gonna do it correctly, but it's gonna give you the wrong answer because you typed it in wrong. Make sure you use parentheses there. I am checking for truthfulness though. There's my question mark. So n over d, 2 over -5 plus 3, get out of that fraction, plus n over d, -5 over -5 plus 8, enter. And on the left side, it gives me -8/3. Okay, let's try the right side. So -4 times -5. I need that in a fraction. So n over d, -4 times -5 minus 4. Now the denominator, again, -5 in parentheses, squared, plus 11 times -5 plus 24. Enter, and you'll never guess what I got. -8/3. How great is that? I believe it. That's impressive.
That is.
So this is true though, and it's good that it's true because now at least this one answer that we got right. I know that this is a solution, so I'm going to box that in. And as fun as that was, let's do it again because we got a second solution on this one. Here we go. So I'm going to replace those x's with -4s this time. So on the left, that's -4, right? So n over d, 2 over -4 plus 3, get out of the parentheses, plus n over d, -4 over -4 plus 8, enter. Oh, on the left, we got a whole value. That's kind of surprised me, -3. All right, what about the right side? N over d, -4 times -4 minus 4, all over. Again, -4 in parentheses, squared, plus 11 times -4 plus 24, enter. And, you know, even before I pushed enter, I was anticipating this showing as -3, and it does, thank goodness. If it was false, then I would know that that's, it wouldn't be a solution, or perhaps maybe I made a mistake somewhere. So the fact that this is true is nice because I can just box that in, and I now have two solutions. And we checked both of them, and they both work. I feel good about that.